Hi, my name is Daniel Cheng. I'm a design engineer at Linear Technology. Today, we're discussing the LT8640, a 42-volt, 5-amp synchronous step-down regulator that features our new silent switcher architecture. Traditional solutions control EMI with a metal shield or slow switching edges, but both have undesirable trade-offs. The LT8640 keeps EMI emissions low while offering a high-speed, efficient, and small buck regulator solution. The LT8640 features an ultra-low quiescent current of 2.5 microamps. This is the total supply current consumed by the device with no load in full regulation. This is particularly important for always-on systems. The LT8640 can operate at 99% duty cycle, resulting in a low dropout of 100 millivolts at 1 amp under all conditions. This is similar to an LDO regulator. A fast minimum switch on time of 30 to 40 nanoseconds allows practical operation at high switching frequencies, with the ability to be synchronized from 200 kilohertz up to 3 megahertz. In EMI-sensitive applications, such as automotive environments, the LT8640 can be run reliably either below or above the AM band. The LT8640 comes in a small 3mm by 4mm QFN package and requires only resistors, capacitors, and one inductor to complete the full circuit. Let's look at efficiency. The plot on the left shows efficiency from a half amp to 5 amps of load current. Switching losses have been optimized so the LT8640 can operate with high efficiency even at high switching frequencies. We see here the peak efficiency for a 12 volts in to 5 volts out application is very high at 96% operating at a 1 megahertz switching frequency. Switching at 2 megahertz delivers almost 95% efficiency, and even at 3 megahertz switching, the LT8640 delivers peak efficiency of just under 94%. On the right is a logarithmic plot where efficiency at small loads can be observed. Because of its ultra-low quiescent current and burst mode operation, the LT8640 can achieve efficiencies of around 80% at just 100 microamps of load and 90% with a 1 milliamp load. Looking at both plots, we can see that the LT8640 offers industry-leading efficiency across a very wide range of load current. Let's look at the switching edges. One benefit of the silent switcher architecture is that it ensures fast switching edges for good efficiency, yet still achieves minimal ringing on the switch node. Here, we compare the switch node rising edges of the LT8640 and another current state-of-the-art switching regulator, the LT8610. The quiet switch edges of the LT8640 result in great EMI performance while minimizing AC switching losses and offering high efficiency at high frequency. LT8640's high-speed switching capability allows the use of smaller inductors to minimize board space. It can also safely use small inductors due to its high-speed peak current mode and a robust switch design which can tolerate inductor saturation during fault conditions. Here is a plot of the LT8640's radiated EMI performance. The LT8640 reduces EMI by more than 20 dB compared to the previously mentioned LT8610, and here we can see that it easily passes the CISPR 25 Class 5 peak limits. It also has a spread spectrum feature, which further lowers EMI by another 6 dB. By varying the switching frequency 20%, the radiated energy is spread across a broader spectrum and thus reduces the overall peak emitted energy. The sync mode pin allows the user to choose between burst mode, pulse skipping, synchronization, and spread spectrum modes. The LT8640 is specifically designed to minimize EMI emissions and maximize efficiency at high switching frequencies. Here we see the recommended PCB layout on our demo board. For optimal performance, the LT8640 requires the use of multiple VN bypass capacitors. 2 small capacitors should be placed very close to the LT8640, one on each side. These 2 capacitors use a small case size, such as an 0603, to minimize the parasitic inductance. A third capacitor of larger value should also be added. These hot loops between the VN, ground pins, and the input capacitors should be made as small as possible. These layout techniques help maximize performance from the LT8640. We can also see that the overall solution size is very compact due to the small QFN package and 2 megahertz switching, which here allows the use of a small 1.5 microhenry inductor. In summary, the LT8640's silent switcher architecture enables low EMI emissions and high efficiency at high switching frequencies. This 5 amp synchronous buck has an ultra-low 2.5 microamps quiescent current, wide input voltage range to 42 volts, and low minimum on-time and dropout, all in one small QFN package. For more information, please visit us at linear.com. Thank you for watching.